Hi, I'm Colin Walls and I'm here again to talk about embedded software. Today I want to talk about the idea of creating a very simple real-time operating system. Now first of all, I generally like simple things. I'm a simple kind of person. The simpler something is, the easier it is to create in the first place, the easier it is to maintain. Everything about simple things is good. Having said that, I've always found the idea of multitasking fascinating. The idea that a computer or microprocessor can perform multiple operations apparently simultaneously almost appears like magic. Now, of course, I've worked in embedded software all my career. I've worked within real-time operating systems a very large amount at that time, so I understand exactly how they work, but it doesn't stop them appearing to be magic. This is, however, another context where simplicity is something we can think about. A conventional commercial real-time operating system is not simple. It's not an incredibly complex beast, but nevertheless it could not be described as a very simple piece of software. And there are circumstances when I guess maybe such a real-time operating system isn't your best option. Those circumstances are when your requirements are very simple. If your application is quite small and not demanding, maybe this is the one time when writing your own scheduler might be the way forward. Now, I wouldn't normally recommend this because normally I would say stick to what you know, let a specialist write your kernel for you. However, in this special situation where your application is very simple, maybe all you need is what's called a run to completion scheduler. The idea of an RTC scheduler is very simple. A task is run, it does what it has to do, and when it finishes, it simply terminates, and the next task gets to run. It does the same thing, and you go round and round and round. This requires that each task only occupies the CPU for a modest period of time, and therefore has to be cooperative and well behaved. Because if it doesn't relinquish the CPU, the other tasks never get to run. But there are plenty of simple applications where this is quite acceptable, and it is a possibility of writing our own code. Hence I called this video the one-line RTOS, because you can write a run-to-completion scheduler in a single line of code. Although it's probably a bit clearer if one writes it in a handful of lines instead, just for clarity's sake. So we start out by simply creating an array of pointers to functions, where each of these functions is one of our tasks. And in the example I have here, I just have 3 tasks, and I've called the 3 functions alpha, beta and gamma. That bit's easy enough. Then we write the scheduler itself. All we have here is a loop. It goes round and round and round forever, and it sequentially executes each of the functions in the array. Really couldn't be simpler than that. The syntax of pointers to functions in C is truly horrible, but actually once you've got that out of the way, it's pretty straightforward. I would say that if you're looking at writing a scheduler any more complex than this, you're probably making a mistake, and unless you have very good reasons, you should start looking at what has already been done. Somebody has written a kernel, has written a scheduler which will do the job better. But as it is, here you have it, the one-line RTOS. Enjoy. I'll be back again soon with another video about embedded software, and look forward to seeing you then. Bye for now.